All right, last video for the week. It's a warm-up. You know what to do. Pause that video, try to do these, and then we'll come back and do them together. All right, hopefully you were able to work those out. So find X and Y on our 30, 60, 90 triangle. We know this is the long side, and the long side is the short side times root 3. So if I divide both sides by root 3, I get 18 divided by root 3. And when I rationalize that, I get 18 root 3 divided by just 3, which becomes 6 root 3. So here, this is 6 root 3, that's our short side. And then our hypotenuse is 2 times that short side. So this is going to be 12 root 3. All right. Tangent of 45, we know that the sides are the same, and if tangent is opposite over adjacent, and those sides are the same, we know that this ratio is just 1. Now sine of 30 degrees, that's your opposite over hypotenuse. Oops. We know the side opposite of 30 degrees is the short side, which is just S. And the hypotenuse is 2 times that short side. So here our exact ratio is 1/2. I do want you to take note in your notes that we've seen a couple different ratios. So possible ratios that we would see is 1, root 2 over 2, 1/2, root 3 over 2. And then we didn't talk about tangent of 30 or tangent of 60. But if we add those here, if I had tangent of 30 degrees, my opposite side is the short side, and the adjacent side is the long side. And then if I rationalize that, I end up getting root 3 over 3. So there's another possible ratio you would see with special right triangles. And then if we did the opposite, the tangent of 60 degrees, that's going to be the long side all over the short side. So just root 3. So when looking at exact ratios of special right triangles, there's really only 2 exact ratios for your 45, 45, 90. And then the rest of these are associated with the 30, 60, 90 degree triangle. All right. That was a little extra for today. Okay, some notes. This is what we call standard position. And this is really applicable when looking not only just at the XY axis system, but also when we start going to the unit circle. So what I want you to know here is that the standard position always starts with the initial side here on the positive part of the x-axis. We also are going to call that 0 degrees. And then it moves counterclockwise to the terminal side. Terminal side, all that means is that's where one of your rays, I don't know if you remember that term, but a ray has a point and goes off in a direction. That means that's where your ray ends. And everything in between indicates the angle that you are wanting to talk about. So a couple things to note about that is if you're going counterclockwise, initial side to terminal angle, that means your angles are always positive. But then if we go clockwise, initial side, terminal side, then the angles are always written as a negative. So make sure you guys get this in your notes. It's really important. Right. So we are going to use that initial side and that terminal side to find the measures of angles. We're also going to use a little bit of knowledge about our XY axis system and our special right triangles. So when you are looking at something and all they give you is your XY values here, you want to draw a triangle from the point that it's indicating down to the nearest x-axis, never to the y-axis, always down or up to the nearest x-axis. So I'm going to draw my triangle in there. It's obviously a right triangle. And what does this point mean? It means that this side is 3 units long, and coming up to the y is also 3 units long. That's what this 3, 3 or my xy coordinates mean. Well, what triangle has sides that are equal? We know that this must be 45 degrees in here because that fits with the special right triangle of a 45, 45, 90. This is moving clockwise, so my angle here is going to be a positive 45 degrees. All right, going to B, we're going to use our knowledge of the quadrants of the XY axis system, knowing that they're all 90 degrees. We are moving clockwise in this situation, so whatever angle we come up with is going to be negative. So we can put that negative there right now. And then we're just going to count it up. So starting at my initial side, this is negative 90 degrees, this is negative 180, and up here is negative 270. All right. Now these last two, I hope you recognize with these last two angles that they have to come from 30, 60, 90 degrees somehow, because what shows up in them? It's this root 3. That's the clue to me that I'm working with 30, 60, 90 degree triangles in order to try to figure out what these missing angles are. So again, if we look at C, I'm going to start here at my point and draw up to my nearest x-axis. So that is 90 degrees. And just ignoring the fact that my y value is negative 2. It's negative 2 because if I was in this quadrant, the fourth quadrant, my y values would be negative, but my x values would be positive. But if we're talking distance, then it's 2 units long. So my y side is 2. This up here, my x value is 2 root 3. And I hope you see that this is the short side of a 30, 60, 90 triangle. And remember, the long side was the short side times root 3. So it fits that. So if this is the short side, then the angle opposite has to be 30 degrees in there. Because we are traveling clockwise, this is going to be a negative 30 degrees. So my angle that goes in here is negative 30 degrees. All right, we have one last problem, and this is going to use the fact that we know that this full angle here is 180. And we're going to try to find this angle here so that we can find what's left over to figure out that angle. First, we note that it's positive. I'm traveling counterclockwise. And then we take our point and we draw our right triangle in. Now my x values over here in quadrant 2, they're negative, but this still just represents like a distance. So this side here is 1/2. And then the long side over here is root 3 over 2, my y value. So if your long side is over here, then the angle opposite that for 30, 60, 90 must be 60 degrees. So this is 60 degrees in here. So if this whole thing is 180, then this angle must be 180 minus 60 degrees. So right here we have a positive 120 degrees. hope that made sense. Like, this is really important stuff, and if you get this, then you're doing really, really well. If not, it takes a few tries. All right. So here's a chance to try that and then check your work. So go ahead and pause the video, and you know, by looking at your notes previously or rewinding the video, try to do these problems. All right, hopefully you had some opportunity to at least try. Maybe you didn't get them, but you want to try. So first thing I notice on A is that I'm traveling clockwise, so no matter what, this is going to be a negative angle. I draw my triangle into my nearest x-axis, and you should realize in the third quadrant both your values are negative, but that makes my sides equal. So this must be 45 degrees in here. So I could do this a couple of ways. If this is 45, this is 90, here is another 45 degrees. So here we have negative 90, and then I'm going to add another negative 45 to that, so I can see this would be negative 135 degrees. B was kind of nice because they gave you the angle over here. You didn't have to figure it out. You see that you're traveling counterclockwise, so it's going to be positive. And we kind of just did this problem. This, though, you could look at it as 180 minus 45. Well, this is still going to give me that 135 degrees, except for it's positive this time. All right. And then in C and D, again, you saw that root 3, and you said, well, these have to be based off of 30, 60, 90 triangles. I'm traveling counterclockwise on this one, so it is a positive angle. I just need to figure out what this angle is here. So I draw my triangle in. I know that this up here is my short side, and this is my long side. So the angle here must be 60 degrees. So I'm going to write that in there, 60 degrees. So I know this is a positive 90, a positive 180, plus another 60 degrees is a positive 240. And then last but not least, we're going to get a negative angle here because I'm traveling clockwise. I can see that these numbers are a little different, but I know it's a 30, 60, 90. So it's telling me that this value here is 1 and this is root 3. This still follows that this is the short side because the long side was root 3 times it. So this angle here has to be 60 degrees. So either you can take 360 degrees and subtract 60, or you can say if this is 60, this must be 30, and then I can go negative 90, negative 180, negative 270, plus another 30 gives me a negative 300 degrees. All right, this is the longest video for this week. But we have one last thing, and it's another vocabulary word, so make sure you still have some space to take some notes. It's this word coterminal. And coterminal angles are angles that have the same terminal side. Another way to think of them is that it is a difference of 360 degrees. I guess it already said that there. Look at the effort I'm putting in for you guys. So, and they give a great example here that this is positive 135, initial side, terminal side. This is negative 225, initial side, terminal side. They both end up at the same terminal side, and that's the definition of a coterminal angle. So let's look at it with this example here. This should have said they're all coterminal. Looks like it got cut off. So I'm going to draw a picture down here. Here's my X and my Y. And we're going to add all of these angles and see why they're coterminal, and it's also going to be helpful to you for figuring out which one of these is not coterminal, although it's pretty obvious because they didn't list it. So negative 330 comes all the way around here, but it's 30 degrees short of being a full negative 360. Oops, I should have wrote. This is negative 330 degrees, and this is 30 degrees. So right there you can see why 30 degrees is coterminal with it. This goes this way. Now I can also add 360 to this 30 degrees. So if I add 360 to 30 degrees, I get 390. So that means I went around, start from my initial side. I went around 360 plus an extra 30 degrees. So I went around more than once. That's 390. And then just imagine, I don't want to mess this up, but I did it again for 750. So I went around, here's 360, 390. I went around again all the way up here to 750. All right, so you can see down here on example 3 which of the following angles is not coterminal with the other three. It's the negative 540. We didn't show it. We know that these three are all coterminal. What if, though, I asked you which of the angles is coterminal with negative 540 between 0 and 360 degrees, which will be in your assignment for this? You're going to add 360 to this value until it becomes positive, until it's between that 0 and 360. So negative 540 plus 360 is negative 180. Guess what? We're not there yet. So if I add another 360 degrees, this does mean that negative 180 and negative 540 are coterminal. But let's add another 360 to see what it is between 0 and 360. That I get a positive 180 degrees. So negative 540 is coterminal with negative 180 is coterminal with positive 180. All right, make sure you ask questions this week. I also have office hours Tuesdays and Thursdays at 1. I've sent out the link, but if you need it again, just email me and I'll send it to you.